Hi, this is Professor Sartor, and I'm back with another 10 problems for my college algebra class. This question says, solve the exponential equation. So we know this is an exponential equation because we have variables in the exponent. I've got a table down here which has the different methods for solving exponential equations. We have relating the bases, which requires us to make both sides have the same base. We're not going to be able to do that with this example because the base on the left is 1.41, which is a decimal with 2 places, and the base on the right is square root of 2. Square root of 2 has infinite decimal places. So we're not going to be able to make the bases the same. So we have these other two methods, converting the exponential to a logarithmic equation or taking the log of both sides. I prefer taking the log of both sides, so we're going to use that method. So our equation, 1.41 to the x equals square root 2 to the 1 minus 3x. I'm going to take the log of both sides. You can use any base, but I prefer to use natural log. So I'm taking the natural log of each side. Now, because we've introduced the log, we are now able to use all the properties of logs. And the one that we're going to use is called the power rule. So if you have a power on the inside of the log, you're going to be able to pull that power in front of the log or multiply by that power. So I was able to get that variable out of the exponent with the power rule for logarithms. I'm going to do the same thing with the power on the right. Get 1 minus 3x times natural log square root 2. So now on the right-hand side, I'm going to use a distributive property and distribute that natural log square root of 2 to each term inside the parentheses. That would give me natural log square root of 2, because 1 times natural log square root of 2 will be natural log square root of 2. And then minus 3x times natural log square root of 2. On the right, I'm just carrying that down. On the next step, I notice that I've got a variable of x on the left, and I also have a variable x on the right. I want those x's on the same side, so I'm going to add 3x to both sides. Not just 3x, that whole term. 3x natural log square root of 2 plus 3x natural log square root of 2. Now these are not like terms, so I'm just going to write it out. X natural log of 1.41 plus 3x natural log square root of 2. On the right, those two will cancel each other out, and I only have natural log square root of 2. So once I have all those x's on the same side, I can factor out that x. It gives me natural log 1.41 plus 3 natural log square root of 2 equals natural log square root of 2. Now that I have an x by itself here, I'm going to get rid of this parentheses by dividing by natural log 1.41 plus 3 natural log square root of 2. I'm going to do the same thing on the other side of the equation to make sure I balance. So that's going to cancel out this whole parenthesis, leaving me with x by itself on the left. On the right, I have natural log square root of 2 over natural log 1.41 plus 3 natural log square root of 2. I'll put that in my calculator so I can round to 4 decimal places. Natural log square root of 2 over I need parentheses for my whole denominator, natural log 1.41, close parentheses for that natural log, plus 3 natural log square root 2, oops, let me back up there and delete a few things. Okay, there we go. Natural log square root of 2, close parenthesis for the log, close parenthesis for the whole denominator. And to round that to 4 decimal places would be 0.2505. Thank you for checking out my videos. Have a great day.